Problem 22, calculate the current in the 2 ohm resistor. We have to find the current through this resistor and the potential difference between A and B. Before, here we don't have the idea what is the direction of the current here. So we have to choose an arbitrary direction of current at each branch. You must have, for example, here we have A. Let's say we have here also A, the same A. Here we have B, and here we have B. We can choose any direction of current. For example, we can say here we have I1, down we have, or we have I here, I1 and I2. So here we have I want to find I1, and here we have I2. We can put the direction of I. Here we have I is up, and here we have I in this direction. Okay, so here I, and here we have I. I is coming from the positive to the negative side. And here also we take I1. I1 is in this direction, also coming from the positive to the negative. What about I2? I2 is coming in this direction. So here we have plus 2 minus. Okay, this is the first thing. The second point, we have to label each node between each two elements. For example, here we have A, here we can put B, here we have B, B, here we have, no, we have B. Let's say we have C. Okay, we have C. We come here, we have B, and here we have A. This one also is A, because we have nothing between these 2 points. And here we have A. We can put here D. Here we have D, and here we have D. And here we have B, so here we have B. Now, to solve this problem, you have to apply the Kirchhoff's law. First of all, we have to take junction rule. We can take the junction at A. We have I in equals to out. We have I1 plus I2. So we can write I1 plus I2 minus I equals to 0. This is the first equation. You know, we have a noun I1, and I2. So we need 3 equations to find these variables. Me, I need I1. Anyway, in this case, we can take many loop. For example, we can take loop 1 like this, clockwise, okay? I take clockwise, loop 1. We start by A, from A to B, B to D to A. Okay, so first of all we take this one, A to B to D to A, and we go clockwise direction. In this case, as you see, the loop rule, summation of delta V equals to 0. We start by AB, delta V AB plus BD plus DA equals to 0. Delta V equals to V final minus V initial plus V final minus V initial plus V final minus V initial equals to 0. To solve it fast, first of all, you look to the first voltage, this one, and this one. We are going clockwise in this direction. We start with A. Look here. We start with A. A from this point, from A to B. Here we have A, from A to B. A is at the positive side, so we put here plus. What is the voltage at this resistance? Equals to R times I. Here we have I1. Look, we have I1. It's here. So we have 2 I1. VD minus VB. Between D and B, we start by B to D. VD, the first one, VD is at the negative side, so we put minus. The voltage here at the resistance equals to R times I. We have here I. Between, now we go from D to A. D to A, here we have A also. We look to the voltage at A. A is at the negative side, so we put minus. The voltage here equals to 8. So this is the second relation between I1 and I. Now we go to the another loop. We can take this loop and clockwise loop. From, we start by A, we go A to C, C to B, and B to A. So we take here the loop A, C, B, A. Okay? The summation of delta V equals to 0. Delta V AC CB BA. Equals to VC minus VA, VB minus VC, VA minus VB equals to 0. Now we have to look to the first one, this one, this one, and this one. We are going from A until A clockwise, okay? VC here is at the negative side, okay? I take from A to C. From A to C, C is at the negative side. So here we have minus. The voltage here equals to 12. VB minus VC. B is at the negative side. So we have minus the voltage at this resistance equals to R times I. Here we have I2. It's here. VA minus VB. VA and VB. We are going from here to here. A is at the positive side. So we have plus the resistance, the voltage equals to 2 times I1. Here we have I1 equals to 0. So here we get 3 equations. This is the third one. 1, 2, and 3. This one is in function of I1 and I2. This one between I and I1, and this one between I1 and I2. We can calculate the value by the calculator to get the value of I1. Finally, here we have I1 and I2. Here we get the value of each I. Look well. The value of I is in the negative. We have a negative sign. It means we have to change the direction of I. I will be out, not in. We take it in. It must be in this direction. Okay? I2 is negative. Also, I2 must be in because I take in the calculation, I took I2 in this direction. So we have to change it because it has a negative value. So it must be in. I1 has a positive value, so it has the same direction. So we have E2 in, I and I1 out. And here we can, about the value, we must have the positive value. Okay? We cannot have a negative value anyway. You can write here I equals to 3.4 ampere to the left. And here you can say I1 equals to 909 milliampere down. and we have I2 equals to plus 451 milliampere, I2 must be down. Okay, you have to write the value in the positive direction, and you have to precise the direction of each one if you have a negative value.